Chapter 11 is about polynomials and rational functions. So in section 11.1, we're going to need to know how to do polynomial long division. So this is our polynomial long division refresher bonus section. So how do you divide a polynomial by a binomial? We learned this back in chapter 4, but it's been a minute, so let's go over it again. So the first thing you want to do is you want to make sure you arrange all terms of both the dividend and the divisor, so what you're dividing by and what you're dividing, in descending powers of the variable. Next, you need to divide the first term in the dividend by the first term in the divisor. This is going to be the first term of our quotient. Then you multiply every term in the divisor by the first term in the quotient, and you write the resulting product beneath. Like this is an iterative process, right? And I am going to go through some examples. You then subtract the product from the dividend, being sure if you have something like 2x minus 7, when you subtract that, you have to distribute that negative. Next, you're going to bring down the next term and write it next to the remainder to form your new dividend. And you're going to use this expression as the new dividend, and you're going to repeat this process, right? It's iterative until your remainder is less than the degree of the divisor. So let's work through an example. So if I have x squared minus 17x plus 74 divided by x minus 5, I'm going to set this up, right? So I've got x minus 5, and we're dividing x squared minus 17x plus 74. So I think to myself, okay, what do I multiply x by to make it look like x squared? Well, that's going to be x. X times x is x squared. X times negative 5 is a negative 5x. We then subtract, forgetting not to distribute that negative. Your first terms are going to cancel. If your first terms do not cancel, you made a tiny mistake and you need to go back and fix it. So negative 17x plus 5x is negative 12x. And I pull down my next term, so plus 74. This is my new dividend, and I think, okay, what do I multiply x by to make it look like negative 12x? And the answer is negative 12. Negative 12 times x is negative 12x. Negative 12 times negative 5 is a positive 60. When I subtract this, I distribute that negative, right? So this becomes a negative 60. My first terms cancel. 74 minus 60 is 14. So 14 is our remainder, right? So I've got x minus 12 plus positive 14 out of x minus 5. All right, I have 2x squared plus x minus 10 over x minus 2. So I have x minus 2, 2x squared plus x minus 10. What do I multiply x by to make it look like 2x squared? That's going to be 2x. 2x times x is 2x squared. 2x times a negative 2 is a negative 4x. Let me go ahead and subtract. My first terms cancel. X plus 4x is 5x. And I pull down my next term, which is a negative 10. Okay, what do I multiply x by to make it look like 5x? That's going to be 5. 5 times x is 5x. 5 times negative 2 is a negative 10. I subtract, and everything cancels. So my remainder is 0. So I have x minus 2. If I divide 2x squared plus x minus 10 by x minus 2, I get 2x plus 5, right? These are factors. So if I had 2x plus 5 times x minus 2, I would get back to 2x squared plus x minus 10. And we would have seen that if we'd tried to factor this quadratic, right? This degree 2 polynomial. Next, I have 7x minus 9 minus 4x squared plus 4x cubed divided by 2x minus 1. So right away, there should be something that kind of makes you go, ew, right? Things that make mathematicians say ew. First thing to note is this dividend isn't written from largest degree to smallest. My divisor is. But I need to rewrite this dividend from largest degree to smallest. So I've got 4x cubed minus 4x squared plus 7x minus 9. Now I can divide. So what do I multiply 2x by to make it look like 4x cubed? The answer is 2x squared. 2x squared times 2x is 4x cubed. 2x squared times a negative 1 is a negative 2x squared. We subtract, distribute that negative. My first terms cancel. Negative 4x squared plus 2x gives me a negative 2x squared. And I pull down my next term. Okay, what do I multiply 2x by to make it look like negative 2x squared? The answer is going to be a negative x. Negative x times 2x is a negative 2x squared. Negative x times negative x is a positive 1x. When I subtract, my first terms cancel, right, because I get a positive 2x. 7x minus x is 6x minus 9. What do I multiply 2x by to make it look like 6x? The answer is 3. 3 times 2x is 6x. 3 times negative 1 is a negative 3. We're going to go ahead and subtract, means I'm adding 3. Negative 9 plus 3 is negative 6. So I have 2x squared minus x plus 3, and my remainder is a negative 6 out of 2x minus 1. In this last example, I included because we need to know where to put in placeholders, right? Every possible degree between x cubed and x to the 0 power, so our constant, needs to be included. So I have 2x minus 1, then I have 8x cubed plus 0x squared plus 0x minus 1. I've got to put in a placeholder. What do I multiply 2x by to make it look like 8x cubed? The answer is 4x squared. 4x squared times 2x is 8x cubed. 4x squared times a negative 1 is a negative 4x squared. We subtract, distribute. I get a positive 4x squared, and I pull down my next term. Even though it's a 0x, because it's a placeholder, I pull it down. What do I multiply 2x by to make it look like 4x squared? The answer is 2x. 2x times 2x is 4x squared. 2x times a negative 1 is a negative 2x. I go ahead and subtract, distributing my negative. I get a remainder of 2x, and I pull down my final term. What do I multiply 2x by to make it look like 2x? The answer is 1. So this is an even divisor, which is great. 1 times 2x is 2x. 1 times negative 1 is negative 1. Everything cancels, and my remainder is 0. So x cubed minus 1 divided by 2x minus 1 is 4x squared plus 2x plus 1.